This video covers learning outcome number 1, visualizing frequency distributions and relative frequency distributions using histograms. So here's the definition of a histogram. A histogram is just a graph consisting of bars of equal width drawn adjacent to each other, and that's really important unless there are gaps in the data. Basically, it's a graph of a frequency distribution or a graph of a relative frequency distribution. On the horizontal scale, we'll see classes of quantitative data values. They might be labeled in a number of different ways. Sometimes you see the class boundaries, sometimes you see the class limits, and often you'll see class midpoints. Technology tends to use these. And then on the vertical scale, you'll see either frequencies or relative frequencies. So this is really just a bar graph where those bars are drawn adjacent to each other. There are no gaps between bars, and it's basically allowing us to visualize what we have in table form with a frequency distribution or a relative frequency distribution. So here is our frequency distribution for duration times of eruptions of Old Faithful, that geyser at Yellowstone Park. So we've got all the duration times. So we had one eruption from 125 in the 125 second to 149 second range as far as its duration was concerned. There were 3 eruptions that lasted between 200 and 224 seconds. There were 34 eruptions that lasted between 225 and 249 seconds. We can look at this in a table, which is insightful, or we can look at this in the form of a graph. This is the corresponding histogram for this frequency distribution. Notice that we've got the lower class limits as tick marks separating the bars on this particular histogram. So we've got 125, 150, 175, 200, 225, 250, and 275 here. I actually made this on a website. If you click on the link, you can find the website where you can create histograms like this. We won't be too concerned about creating our own histograms in this course, but it is possible to create histograms with data sets online. But these tick marks, again, are the lower class limits for each of the classes in our frequency distribution. Because we've got the lower class limits here, if we subtract the values on these tick marks, the consecutive values, so we do 150 minus 125, that's going to give us the class width. So you've got some other information that you can infer from there. Now notice you've got the frequency on this, what would traditionally be the y-axis, that's our vertical axis. And then you've got those durations, the lower class limits of those duration times on the horizontal axis. So in that first class, we had one eruption that lasted between 125 seconds and 150 seconds. And then in the next 2 classes, there were none. And then you see we've got 3 eruptions between 200 and 224 seconds long, 34 eruptions between 225 and 249 seconds long, and then we've got 12 in the last class. So this is saying exactly the same thing as this table is saying, but it's showing us in a more visual way. Notice also that you have no gaps in between these bars except for in those over those ranges or in those classes where the frequency was 0. So you might see some gaps due to that, but otherwise you shouldn't see gaps between the bars at all in a histogram. So that's one example. Here's another example. These are McDonald's lunch service times. So they had 11 customers that received a service time between 75 seconds and 124 seconds. There were 24 customers that received a service time between 125 seconds and 174, and so on. You can go through the table. Rather than looking at that data in this way, we might look at it in the form of a histogram instead, which tells us exactly the same thing in this much more visual way. Notice that the bounds on here on that horizontal axis are not the lower class limits this time. Looks like they've used the class boundaries. Remember, those are the values that separate the classes without the gap between them. So we've got a gap between this first class and this next class. There's a 1 second gap between 124 seconds and 125 seconds. If we split the difference, we'll have that 124.5. So that's a class boundary. So they're using class boundaries here rather than class lower limits, like class lower limits were used on the last histogram. And then notice that the y-axis or the vertical axis represents the frequency. So this first frequency was 11, and if you look at this red rectangle right here, if you see where it butts up against that vertical axis, it looks like frequency of about 11. And then this one is very tall. If this is a frequency of 25 and that's a frequency of 20, it makes sense that that looks like about 24, and that's what it says in the table, and so on. So you're able to create a histogram like this using this data. Now, in addition to regular histograms that have frequencies on that vertical axis, we can also have relative frequency histograms. This is where instead of having frequencies on the vertical axis, you have relative frequencies on the vertical axis. So let's look at the relative frequency distribution for those McDonald's lunch service times. It's exactly the same classes as before, but rather than telling us that we had 11 customers that were served between 100 or 75 seconds and 124 seconds, were served with that sort of duration time for their lunch service. Turns out that 22% of that sample, which happened to have 50 customers in it, had a duration or a lunch service time within that range. And 48% of customers that were surveyed for this had a lunch service time between 125 seconds and 174 seconds, and so on. So we could represent this graphically in this way. Notice that this graph is almost identical to the graph on the last one. Look at that picture. And now look at that picture. They're almost identical. The horizontal axis is exactly the same. The only thing that's changed is that rather than having frequencies on this vertical axis, we have relative frequencies on the vertical axis. So this first rectangle, or this first bar in this histogram, which we can think of as a bar graph without any gaps in it, that first bar, rather than extending to a frequency of 11, is now extending to a relative frequency of 22%. And the second bar, rather than extending to a frequency of 24 out of 50 clients, is now extending to a relative frequency of 48%. So those are histograms. And this is an example of a relative frequency histogram. The next learning outcome is probably the most important learning outcome of this lesson, and that is to use histograms to infer characteristics of data. I will see you in the next video to discuss that one.